Okay, in this topic we'll be learning about the multiplication of exponents. How do we multiply exponents? In the previous topic we learned how to write an exponent. What is an exponent? What is the base of that particular power or exponent or index? So let's start with a few examples in multiplication. So we have now 3 to the 5th power times 3 to the 6th power. Now we all know that this is the base, this is the power, the amount of times you would write that particular number multiplied by itself. So let's expand it out. This is the expansion of it. So we put 3 times 3 times 3 times 3 times 3. This is for the 5 here. And then we're going to say times the 3 to the 6. 3 times 3 times 3 times 3 times 3 times 3. There are 6 trees there. So what do we do now? Well, how many trees are there? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Therefore, our answer will be, you keep the base, which is 3, and how many trees? We said 11 when we counted. But what would happen if this power was up to 100? Are we going to write it down a lot? No, we're not going to write it down a lot. Why? Because there is a rule. Remember, we have seen BEDMAS. Everything has a rule. This thing here has a rule also. So let me give you a note. Then, once we follow the rule, we should shorten our work. So for this one here in particularly, let's use the same example here. This is to say 3 to the 5th power times 3 to the 6th power. Notice this 5 and the 6. Notice the base 3. Since we are multiplying two bases of the same kind or of the same value, we will keep the base and simply add their powers, which now gives us 3 to the 11th power. Easy as that. Notice again, we expand it out and then we would add them out. However, there should be a shortcut, there should be a rule to follow so that we minimize the amount of work here. So this is what you are going to do whenever you get something like this. I don't want to see no one expanding it out. I want you to apply this rule here. If they are being multiplied, you will keep the base and add their powers. Alright? Let's try our next example. 2. We have a to a third power times a to a fourth power. Let's use the rule. Okay? The rule says that if you have the bases, you can say, okay, we can expand it if you want it, but we are not going to be expanding it out because I've already shown you this. So you're going to say now that it is a to the third plus 4 if it's multiplication. This now gives us a to the 7th power. All right? Hence we get a general rule that states now a base to a power times that base to a different power. We keep the base, that's the base here, and we simply add their powers. That's the general rule for multiplication of indices. So when multiplying quantities with the same base, we add their indices. So let me write that down as the rule. So for this, you're going to say, so when multiplying quantities with the same base, we keep the base and add their powers. Be careful, powers, or what you call in the indices, or what you call exponents. They all mean the same thing. Remember, I will not be repeating these words here over and over again, so that you can understand that that's what that means. So now let's go over this piece of the topic. If you are given to multiply a base to a power times that same base to a different power, then what you will do is that you are going to keep the base and simply add their powers so as to get the solution. So you will not be expanding it out this way. I'm not going to be demanding you guys to expand out anything, but simply apply the rule to get your solution. So let's try a few examples here. Let me write out a few examples. And so I'm going to write the rule, the directions, as to say, now express each of the following products. And why do we call it products? Because it's multiplication in index form. So you are not going to take the value and multiply it out or punch it out in your calculator and get me a fraction or a big number. You need to give me the answer with an exponent. Okay, so our first example will be 3 to the 4th power times 3 to the 3rd power. What do? Since the bases are the same, we will keep the base and their powers. This gives us 3 to the 7. So now express each of the following products. You have expressed the following products in index form. This is the index form. Okay, so that's the index form for that particular problem there. Let's go with the next example. We have x to the 4th times x to the 6th. Well, the rule says we keep the base, which is x, and we add their powers because this is multiplication, x to the 10th. Easy as that. Let's go with the next one. 3. We have now a mixture, x to the 4th times y to the 3rd, let me write this 4 clear, times y to the 5th times x to the 3rd. Now be careful with your x's and your times sign. If you notice my x, I make them as curvy. However, what you can use brackets. So let me just express the same problem here using brackets. They mean the same thing. You don't have to use brackets, but that's up to you. Whichever one you feel more comfortable working with, so as to avoid confusion. So if I was to write this in bracket form, then this would have been x to the 4th times y to the 3rd times y to the 5th times x to the 3rd. I have just simply used brackets. I'm not saying that you have to go this way. I'm just showing it that this means the same thing. So now, the rule says that we multiply the bases of the same kind. Well, what are the same kind? Well, there's an x to the 4th, y to the 3rd. They cannot be combined. They don't have the same base. So this x can only be combined with this one here. So this one with this one. So what do? You will then bring the base x. What is the power of the first x? 4. And what do you do if it's being multiplied with the next base of the same kind? Well, we keep the base and simply add its power. And then what's the next base? Y. We write y. What's the powers of the y? 3 and 5, and since they're being multiplied, we will simply add their powers. This gives us as a solution now as x to the 7th and y to the 8th. That is our solution. So remember, for multiplication, we have a very basic rule. The rule says that so long as it's being multiplied, we keep the base and we simply add their powers. Okay, so that's all for multiplication. This is for the rule whether the power is positive or negative. I showed you examples with low and positive values for right now, and then we'll be going to negative values.